Okay, today we're going to talk about two-sample proportion, inference test, and confidence intervals. So two-sample. So as always, before we start a test is we got to start with the assumption. So for two-sample prop, we need two independent simple random samples from populations. We need to know that the populations are at least 10 times each sample size group. So therefore, the sample can't be most of the population. You need a normal approximation for both, so check for normality. Either each group needs to be a rule of 30. Actually, rule of 30 does not apply for proportion. We need to check that N1 P1 is greater than 5, that N1 1 minus P1 is greater than 5, that your second sample group, your sample size 2 times your P2 is greater than or equal to 5, and that your N2 times 1 minus P2 is greater than or equal to 5. So formula for confidence interval is your statistic plus or minus your critical value times the standard deviation. So if you're doing a confidence interval for proportion, your statistic is your P hat. So P1 hat minus P2 hat. Plus or minus critical value for proportion is always your Z statistic for either 90% to 95 or 99 typically. And your standard deviation is big formula that is on your AP formula sheet. P hat 1 times 1 minus P hat divided by N1 plus P hat 2 times 1 minus P hat 2 divided by N2. So note, use P hat when P is not known. And the calculator can conduct this confidence interval for you by going to statistics, confidence interval, and selecting 2-prop Z, 2-prop Z. You'll then put in your sample size 1, your p-value for 1, your sample size 2, and your p for your second sample. So again, if you're looking at the formula, standard error is all the big square root part. And your margin of error is your standard error times your Z statistic. So let's look at an example. At Community Hospital, the Burn Center is experimenting with a new plasma compress treatment. Random sample of 316 patients with minor burns received the plasma compress treatment. Of these patients, it was found that 259 had no visible scars after treatment. Another random sample of 419 patients with minor burns received no plasma compress treatment. For this group, it was found that 94 had no visible scars after treatment. What is the shape and standard error of the sampling distribution of the difference in the proportions of people with visible scars between the two groups? So we can say that it's approximately normal by checking our N1, P1 values. So N1 times P1, again, N1 is your sample size. So 316 times your P1, which would be 259 out of 316. So your 316s cancel, you're left with 259, that's greater than 5, check. N1, second N1 would be a 419, or N1 would be 316 times 1 minus, again, 259 over 316. That will get you 57, that is above 5, check. N2, P2, your second sample size is a 419 times 94 out of 419. 419s cancel, you're left with 94, above 5, check. And N2 will be that 419 times 1 minus 94 out of 419 will get you 325, above 5, check. So therefore, we do have approximately normal. So if we find the standard error is the big square root formula, we'll get a value of 0.0296. So what is a 95% confidence interval of the difference in proportion of people who had no visible scars between the plasma compress treatment and control group? So if we're going to do a difference, if we're going to do a confidence interval, we start with assumptions. Again, we've already checked that they were greater than 5. We do have 2 independent randomly assigned treatment groups, and our total population of burn treatments should be at least multiply your 2, should be 10 times each of your sample sizes, which yes, definitely could be more than 7,350. Since these are all burn patients, we can add 316 plus 419 to get 735. And again, you're multiplying that by 10. And yes, the overall number of burn treatments in the world, we can say is that. You just needed this part. Again, the 10 times n is just to guarantee that your sample is not the majority of the population. So to conduct a confidence interval, again, you can use the big long equation. I suggest using calculator. If you check the calculator, do a menu, statistics, confidence interval, to sample, and it's always a z-test, or if it says a prop, you could do a 2 sample prop for confidence interval, but proportion is always z. So make sure as you're writing down the steps, write down 2 sample z-test or 2 sample prop ci and all the variables that the calculator asks for. But whether you use formula or do it by use calculator, we should get that with our conclusion statement. We are 95% confident that the true difference in proportion of people who have no visible scars between the plasma compressed treatment and control group is between 53.7 and 65.4%. So suppose the researchers want to estimate the difference in proportions of people who are against the death penalty in Texas and in California. So if the 2 sample sizes are the same, what size sample is needed to be within 2% of the true difference at 90% confidence? Well, 2% as a decimal is 0.02 equals, if we're at 90%, that's going to be a z-statistic of 1.645 times big square root. Again, if we don't know otherwise, we're going to say that our p-value is 0.5. So 0.5 times 0.5 divided by I don't know sample size plus 0.5 times 0.5 divided by I don't know sample size. Because they told us the 2 sample sizes are the same, we can just use n. If you're using a graphing calculator, I would suggest use your numerical solve and solve for n or put these as x. Again, otherwise you have to take 0.02, divide by 1.645, square both sides, add these together. It's a little more work. I'd use a numerical solve. But since these are the same denominator, you could just put add the numerators. But either way, when you find your answer and we round up, because we are talking about sample size, we should get a sample size of 3,383. So researchers comparing the effectiveness of 2 pain medications randomly selected a group of patients who had been complaining of a certain kind of joint pain. They randomly divided these people into 2 groups and then administered the painkillers. Of the 112 people in the group who received medication A, 84 said this pain reliever was effective. Of the 108 people in the other group, 66 reported that pain reliever B was effective. So construct separate 95% confidence intervals for the proportion of people who reported that the pain reliever was effective. And based on these intervals, how do the proportions of people who reported pain leave the medication A or medication B compare? So if we were to, using your calculator, conduct a confidence interval for A, we would get values between 0.67 and 0.83. If we conducted using the calculator confidence interval for B, we get 0.52 to 0.7. And since the intervals overlap, okay, notice we have goes up to 0.7. 0.7 is within these 2. It appears that there is no difference in the proportion of people who reported pain relief between the 2 medicines. So because we have overlap, there is no difference. No overlap would be a difference. But because I can get some values, no difference. So notice in this example, we actually created two confidence intervals and had to compare. Another way of doing this is by actually constructing a 95% confidence interval for the difference in the proportions of people who may find these. So if we're going to find the difference, that means that we're actually conducting a two sample. And if you do confidence interval two sample, we'll get a confidence interval of 0.017, 0.261. And notice, is 0 in the interval? No, since 0 is not in the interval, then there is a difference in the proportion of people who reported pain relief between the two medicines. So this just shows you two different ways and shows you the difference of what we say when we're wanting to find the difference in a proportion using a confidence interval. 0 is not in the interval, then there is a difference. If 0 is in the interval, then there is. If 0 is not in the interval, then there is a difference. So we can turn a difference of proportions into another kind of hypothesis. So if I want to find that P1 minus P2 equals 0, there's another way I could write that by stating that my null as P1 equals P2. So again, if we just add P2 to both sides, notice that P1 minus P2 is greater than 0. We could write that as P1 is greater than P2. Again, so forth. We could have this less than, or we could have it not equal to. But again, your null should always be equal. Your alternative is one of the three. So notice these state the exact same thing. Okay, you could either state it as the left side or you could state it as the right side. Since we assume that the population proportions are equal in the null hypothesis, the variances are equal. Therefore, we pool the variances. So pooling means when we take p hat equals x1 plus x2 divided by n1 plus n2. And your formula for hypothesis test, again, as always, your test statistic equals your statistic minus the parameter divided by the standard deviation of the statistic. If your test statistic is either z, if you're finding a z statistic, we're going to have p1 hat minus p2 hat minus p1 minus p2, all divided by big square root p hat 1 minus p hat times big square root 1 over n1 plus 1 over n2. Again, this is a big, long formula. It is on your AP formula sheet. You don't need to memorize it. I would suggest using the calculator shortcut. If we were going to do this on the calculator, we go to menu, statistic, go to test. Okay, if you're going to find confidence interval, you go to confidence interval, test if you want a hypothesis test. And if we're doing proportion, you do two sample prop Z. Again, sometimes you do need to know where the formula is on the formula sheet, as there may be a multiple choice question that has numbers plugged in. So just be aware. Get out your formula sheet and find it. And usually our null is going to be that P1 minus P2 equals 0, so we're not going to need that part. It slightly makes it easier. But again, I would suggest a calculator. Menu, statistics, test, and then two sample prop if we are talking about proportion. So let's look at an example. A forest in Oregon has an infestation of spruce moths. In an effort to control the moth, one area has been regularly sprayed from airplanes. In this area, a random sample of 495 spruce trees showed that 81 have been killed by moths. Second nearby area receives no treatment. In this area, a random sample of 518 spruce trees showed that 92 had been killed by the moth. Does this data indicate that the proportion of spruce trees killed by the moth is different for these areas? So does the data indicate, suggest that we can do a test? There's in one way you could do a confidence interval for this one, but hypothesis test is a more direct route. So as always, we first need to start with assumptions. I have the word proportion, and I know that I have two sets of data, right? Two samples, so it's going to be a two sample proportion test. But first I must show my assumptions in order to state that I can use that z-statistic. So assumptions are, yes, I have two independent randomly assigned treatment groups. I need to check all my numbers here, N1, P1, so 495 times 81, 495 equals 81. N1 times 1 minus P1, 495 times 1 minus 81 out of 495 equals 414, and so forth. Check it, the same thing for my second sample, and everything is above 5. Check that your population is 10 times your sample sizes, and yes, if we're talking about the number of trees, yes, we can definitely say that we're going to have more than 5,180 trees. So continuing with our test is we need to check that our null for testing is something different. That means that our null is that it does P1 or equal P2. We're testing against the alternative that P1 does not equal P2, where P1 is the number of dead spruce trees from the treated area, and P2 is the number of dead spruce trees from the untreated area. So if we continue with our steps, again, you can use the big long formula if you want. I'd suggest a calculator. So go to Menu, Statistics, Test. And because we have two samples and the word proportion, we're doing a two sample prop Z. Again, put down everything that the calculator asks for, your P1 81, or if it says X equal 81, your sample size for 1 and 1 is 495. Your P2 is 92, or your X2 is 92, and your sample size N2 equals 518. After you do that in the calculator, you should get a Z value of negative 0.591, or if you use the formula, a P value of 0.55, and since alpha is not stated otherwise, let's use 0.05. Again, make sure that you have all of these as you're showing work. If you're using calculator, you need to name the test, everything the calculator asks for, put down Z equals, P equals, alpha equals. That is full credit. And a final conclusion statement, we compare our p-value to our alpha, and p is greater than alpha. So since p is greater than alpha, we fail to reject HO. There is not sufficient evidence to suggest that the proportion of spruce trees killed by moss is different for the areas. Again, how do you know what that last sentence is? Use the sentence in the problem. Does it indicate the proportion of spruce trees killed by the moth is different? Okay, all of these steps must be here for full credit. So what about a two sample inference procedure with means? Okay, so we just did a two sample prop. The goal of these inference procedures is to compare the responses to two treatments, or to compare the characteristics of two. We have independent samples from each treatment or population. One cannot depend on the other. So remember, when we have means, X minus Y, we're going to take just the two means and subtract. But never, never, never do we directly add or subtract standard deviation. We think Pythagorean theorem, big square root, your first standard deviation squared plus your second standard deviation squared. So suppose we have a population of adult men with a mean height of 71 and a standard deviation of 2.6. We also have a population of adult women with a mean height of 65 and a standard deviation of 2.3. Assume heights are normally distributed. Describe the distribution of the difference in heights between males and females. So let's start with our mean. Our subtracted mean, 71 minus 65 will get us a mean difference of 6 inches. And standard deviation, again, think Pythagorean theorem, big square root 2.6 squared plus 2.3 squared will get you 3.471. So notice what we did here. We had a distribution of female, we had a distribution of males. What we just did here is we took 2 samples and we turned them into 1 using difference by subtracting. Okay, new mean of 6, new standard deviation of 3.471. So we are taking a 2 sample and turning it into a 1 sample. So assumptions, we need to have 2 SRSs, simple random samples from the population, or 2 randomly assigned treatment groups. We need samples are independent. Both distributions are approximately normal, of course, by either stating normality, that we have a large sample size for each above 30, or that we've graphed the data on a box plot or stem plot and showed them to be approximately normal. And we need to determine whether we have a Z or a T test by a sigma known or unknown. So formulas, since in real life we will not know both sigmas, typically we do a t-test procedure. So since we're using our t-test, that relies on degrees of freedom, so use the smaller of the 2 values, n1 minus 1 or n2 minus 1. Again, sample size of the first minus 1, sample size of the second minus 1, whichever is smaller. This will produce conservative results, higher p-values, and lower confidence. And option 2, approximation used by technology. Which is this big long formula on your formula sheet. So just be aware of where it is on your formula sheet. Don't need to memorize. Sometimes there might be a multiple choice question on the AP test with numbers plugged in. So just be aware of where it is. So to find confidence intervals, again, we would be taking our x bar 1 minus our x bar 2 sample means and subtracting, plus or minus your critical value. 99% of the time will be a t statistic. And your standard deviation will look like this for a difference. So again, this formula is on your formula sheet. Be able to identify where it is. You might have a multiple choice question. Most of the time, I'd suggest utilizing the calculator. So how do we find a 2 sample confidence interval? Go to menu, statistics, confidence interval, and then 2 sample t. So used for 2 populations with the same variance. When you pull, you average the 2 sample variances to estimate the common population variance. But our AP test does not use pooling. We do not know the variances of the population, so always tell the calculator no for pooling. So let's look at an example. We have 2 competing headache remedies claimed to give fast-acting relief. Experiment was performed to compare the mean lengths of time required for bodily absorption of brand A and brand B. Assume the absorption of time is normally distributed. 12 people were randomly selected and given an oral dosage of brand A. Another 12 were randomly selected, given an equal dosage of brand B. Length of time in minutes for the drugs to reach a specified level in the blood was recorded. So the results are shown here. We had a mean for A, 20.1. Mean for B, a standard deviation for A and B with a 12 as sample size. So describe the shape and standard error for sampling distribution of the differences in the mean speed of absorption. Well, shape, look, it says normally distributed, stated, and our standard error you can either find from the calculator or using the big long formula. We should get a value of 3.316, but calculator will find this for you. So find a 95% confidence interval difference in mean lengths of time required for bodily absorption of each brand. So we need to start with assumptions. Do we have two independently randomly assigned treatment groups? Given the absorption rate, it is stated normally distributed already, and our sigma is unknown. We only have a sample standard deviation, which typically is the case. So it is a t-test, or t-interval. So you can utilize the big long formulas if you want, or we can use a calculator, menu statistics confidence interval, true sample t. Again, put everything the calculator asks for, your x1 mean, your standard deviation 1 mean, your sample size of 1, your standard deviation 2 mean, your mean of 2, your standard deviation of 2, and your sample size. So the conclusion and context, again, after you get the calculator output, again, you should get negative 5.6. Let's put it in a sentence. We are 95% confident that the true difference in mean lengths of time required for bodily absorption of each brand is between negative 5.685 and 8.085 minutes. Okay, so all steps must be there for full credit. So note, confidence interval statements. We have two things, okay, and these are commonly mistaken, but I found an easy way to help you remember. Matched pairs refers to a mean difference. It is singular, okay? Matched pairs is when we actually take 2 and subtract, turn it into a 1 sample. So singular, 1 sample. A 2 sample refers to a difference of means. Notice means is plural, so this is going to be a 2 sample. So here's a difference of when I have a 1 sample versus a 2 sample. Okay, so think singular, matched pairs, 1 sample, means plural, 2 sample. So what do your hypothesis statements look like? Again, your null is always equal to. Again, it could look either like the left side or the right side. I think the right side typically is easier, but notice that they could be written either way. You can either subtract and have 0 on the right-hand side, or you can have them equal to, less than, greater, or not equal to, just no difference. So hypothesis test statistics, again, typically it will be a t-statistic, as we do not know a sigma. x1 bar minus x2 bar minus mu1 minus mu2, all divided by a big square root. Since we usually assume that the null is true when this equals 0, so we can usually leave it out. But again, calculator does the work for us. So if we look at this problem, the length of time in minutes for the drugs to reach a specified level in the blood was recorded. Is there sufficient evidence that these drugs differ in the speed at which they enter the bloodstream? So first, start with assumptions. We have independent, it states the word random. We have a normal distribution. Let's just state it otherwise. And sigma is unknown, so a t-test. Let's state our hypothesis, our null and our alternative. We're going to state that our mu A equals mu B. and we're testing to see, is it different, which means not equal to. We need to define what our mu is. Mu A is the true mean absorption time for brand A. Mu B is the true mean absorption time for brand B. So we can use the big long formula if you want, or we can use the calculator to sample t-test. So menu statistics test to sample t. List everything that the calculator asks for. Again, here is how you calculate it by hand if you want to do that. Make sure to state the t-value, 0.361, state the p-value that you get from the calculator output, 0.7210, your degrees of freedom, and alpha, unless stated otherwise, is 0.05. So we compare p to alpha. Here, p is greater than alpha. So since p is greater than alpha, I fail to reject HO. There is not sufficient evidence to suggest that these drugs differ in the speed at which they enter the bloodstream. So robustness, 2 sample procedures are more robust than 1 sample procedures. It's best to have equal sample sizes, but not necessary. So let's look at this problem, a very unique problem. A modification has been made to the process for producing a certain type of time zero film. Because the modification involves extra cost, it will be incorporated only if sample data indicate that the modification decreases true average development time by more than 1 second. Should the company incorporate the modification? So we got to always start with our assumptions. We do have 2 independent simple random samples. We can check by box plot that both are approximately normal. Again, you can graph those on your calculator given the data values. And we have sigma unknown, so we know that we are doing a t-test. State your null and alternative. Notice from the problem, we are checking to see is mu sub O minus mu sub M equal to 1. Our alternative would be that it's greater than 1. And always define where mu O is the true mean developing time for original film and mu M is the true mean developing time for modified film. So again, I suggest calculator. If you want to calculate t by hand, you can, but calculator, this would be a 2 sample t-test, menu, statistics, test. And this time you have data, here you have from data. So you can go into your list and spreadsheets, type in your 2 columns of data, label your 2 columns, and you're doing it from data this time, not from stats. Write down your t-value equals 0, your p-value is 0.5, your degrees of freedom equals 7, and alpha, unless stated otherwise, 0.05. Again, make sure to write these down from the calculator output. So since p is greater than alpha, 0.5 is greater than 0.05, I fail to reject. There is not sufficient evidence to suggest that the company incorporates the modification. And that concludes 2 sample confidence intervals and hypothesis test.